Hello students, welcome to BYJU'S Exam Prep, most comprehensive app for all exams. How are you guys? Now first session on Thevenin's theorem, right? In first class already I have given you the important topics from network or that is circuit theory. First of all inform me that sound quality, picture quality, everything is fine. Now please join the session, that is what GATE 2023, network or circuit theory, is one of the most important subject for electronics, electrical and instrumentation branch. First of all inform me that sound quality, picture quality, everything is fine. Yes please. Yes, एक बार जरा बता दीजिए मुझे, let me know what everything is fine. Now this is a Thevenin's theorem with what dependent source. Number of students are worried about this topic, how to solve the questions on Thevenin's theorem. The next important thing, how to solve questions on Thevenin's theorem with dependent sources, right? So in this class I will discuss some theory and with 2 or 3 numericals I will give you the concept how to solve this type of questions, and tomorrow we will practice number of numericals. Mansi Chauhan, very good evening, how are you? And then please join the session, like the session, okay, and share the link of this session. Okay then, Pratmesh Chauhan, okay, very good evening. Now this is my introduction. Myself Sanjay Rathi, 20 plus years of teaching experience in the field of competitive exam, AIR 16 in ECE 2005 and AIR 21 in ECE 2008, and I have mentored more than 1 lakh students for these exams. These are my area. Okay, so that is my small introduction. Now Thevenin's theorem, right? In network we have number of topics like what KCL, KVL, mesh analysis, nodal analysis, elements, resistor, inductor, capacitor. Okay, once you have the command over what KCL, KVL, mesh analysis and what nodal analysis, then important topic is what Thevenin's theorem, Norton's theorem, maximum power transfer theorem and Thevenin's theorem with dependent source. चलिए आते हैं हम. Now this is a strategy to conquer GATE 2023 by Abhinav Negi sir on 13th March at 12:30 p.m. Okay, so please join that session on 13th March 12:30 p.m. Here Abhinav Negi sir is going to give each and everything about what GATE 2023, what should be the strategy, right, for next year. Okay then. Now what is the Thevenin's theorem? Simply when we are talking about the Thevenin's theorem, right, for any network, suppose we are having this 2-port network, that here we are having 2 terminal, that this is the A, this is the B, and this is a particular network, and that we are connecting one load resistor here, RL. Okay, then we can reduce this network into a single voltage source, and what one resistor here, that is called RTH, and this is called VTH. This is called Thevenin's equivalent. One VTH and one RTH, and then once you will find that Thevenin's equivalent, then you can apply RL here, connect this RL, and then directly you can find the current I, that is the I is equal to VTH upon RTH plus RL, right, and then you can find the voltage across the RL, I into RL. This is very, very simple. Any network, we can convert it into what? A single voltage source and single resistor RL. So what is the VTH, everyone? The VTH is nothing but VOC. VTH is nothing but VOC, that is called open circuit voltage. Now if you want to calculate the VTH, then simply make RL is equal to infinite and find the open circuit voltage across A and B terminal. Open circuit means what? Simply current will 0, right? Now Second thing, what is the RTH? RTH is nothing but equivalent resistance seen at these points, seen from what? A and B. Normally we are finding the equivalent resistor by making all active sources, active independent sources 0. But if in circuit, if dependent source is present, then we have to change the method, right? So number of ways to solve those questions, just I will discuss each and everything in detail with numericals, with some examples. Okay, so yeah, what is the Thevenin's theorem? Thevenin's theorem states that any two-terminal linear network having a number of voltage and current sources and resistance can be replaced by a simple equivalent circuit consisting of a single voltage source in series with a resistance, where the value of the voltage source is equal to the open circuit voltage across the two terminals of the network, and resistance is equal to equivalent resistance measured between the terminals. So already I have given you the idea. Now, hello Hanumantarao, how are you? Prathamesh. So up to this point, that is clear. So please share the link of this session, right? So सबसे पहले like the session, share the link of this session, and subscribe the channel. Okay. Now that is the Thevenin's theorem. Simply that is the equivalent linear source RL. Simply remove the RL, or normally we are representing it what like one voltage source and RS. So this is RS is nothing but RTH, and that is the RL. Single voltage source, single resistor, and that is the RL. Similarly, we can convert a particular network into what? Norton's theorem. Norton's means what? We are simply converting a particular network into a current source and a resistor. Current source and a resistor. So same statement, that is the linear source we have. This is the terminal A and B. Now you can convert this network into a single current source IS and RS. This is the A and B. Now what is the IS? This is also called Norton's current. This is nothing but short circuit current. This is nothing but short circuit current. What is the meaning of the short circuit current? This is the meaning. This is the short circuit, and find the ISC here. Okay, and to find the RL, same method, just like what? Thevenin's theorem. Open terminal, make all the independent sources 0, and then find what? RN. This is called Norton's equivalent. RN or RS. Okay. Now, once we have the Thevenin's equivalent or Norton's equivalent, that is a source transformable pair. These are what? Source transformable pair. How are you, Chinmay? Then source transformable pair means what? If you have the Thevenin's equivalent, you can find the Norton's equivalent. If you have the Norton's equivalent, you can find the Thevenin's equivalent. How is it possible? Simply source transformable pair means, for example, if I want to find Thevenin's to Norton, then if we have the value of VTH, if we have the value of RTH, then source transformable means IN is equal to VTH by RTH. This is called RN or RS. So RN is equal to RTH. Directly. Source transformable pair. Or from Norton's to Thevenin's, current source to voltage source. Very simple. Current source to voltage source. What is the current source to voltage source? IN is equal to VTH by RTH. So what is the VTH is equal to IN into RL. And what is the RTH is equal to RL. You will get the Thevenin's equivalent. Right. Now, that is the question with the dependent source. For example, if I am having one dependent source here, 1.5 Ix, this is the 3 ohm, this is the 4 ohm, this is the 5 ohm, this is the 6 volt. Right? Very good evening, Tamil Chinmay. Please give me the answer for this type of questions. Everyone, please note this question and try to solve. Try to solve and give me the answer. If you have the command over this, then try to solve this question and give me the answer. What is the question? Find the Thevenin's equivalent circuit of the figure. Means you have to find VTH and RTH. So what is the value of the VTH and what is the value of the RTH? Now new students, just I am giving you the some simple question on this, and then we will solve this particular question. For example, if there is no current source, then this question will become very easy. Other student, try to solve this question and give me the answer. If you have the command, then if we are having this type of questions, plus minus 5 ohm, 3 ohm, 4 ohm, there is no dependent source. 5 ohm, 3 ohm, 6 volt. If there is no dependent source, this question will become very, very easy. This is called A and B. You have to find the Thevenins, then you can directly find the VOC at this point, and you can apply the VOC is equal to voltage division rule, 4 divided by 5 plus 3 plus 4, right? 4 divided by 5 plus 3, 8 plus 4 into 6 volt. This will become 4 divided by 5 plus 3, this is the 8 plus 4, 12. 4 divided by 12 into 6, and that is nothing but 2 volt. This is without current source, without dependent sources. This question was very, very easy. And if you want to find a Thevenin's resistor, always make the dependent source 0, then 6 volt will tend to 0, 5, 3, and this is the 4 ohm. And then this RTH means here, new student, please watch this. RTH means simply make the active source 0. This is the 5, this is the 3, and this is the 4. And now what is the answer? RTH is given by 4 parallel with 8. So 32 divided by 12. 32 divided by 12, that is 8 by 3 ohm. 8 by 3 ohm. Okay, if there is no dependent source, I am just removing the dependent source, okay, then this question will become very, very easy. This is the question. But if we have dependent source, then what will be this method? Now there is another method. If you want to find the RTH, then you can find the short circuit current also, because we have the open circuit voltage. What is the open circuit voltage for this question? Very simple question, just for practice. VOC we have 2 volt without dependent source. Then you can also find the short circuit current, my dear students. Short circuit current. What is the short circuit current? This is the 6 volt battery. What is the meaning of the short circuit current? This is the value. This is the 4 ohm. This is the 3 ohm. This is the 5 ohm. Make it short circuit. Everyone give me the answer. What is the short circuit current? Make it just short circuit. What is the short circuit current? So when I want to calculate the short circuit current, it will become 5 plus 3, 8. That is the 6 divided by 8, because there will be no current through the 4 ohm resistor. So what is the short circuit current? No. Utkarsh, I want to calculate the short circuit current for this diagram. So simply it is a short circuit. Then it will become, because the 4 ohm is short circuited, 5 plus 3, 8, 6 by 8. 6 by 8, that is nothing but 3 by 4. This is the short circuit current. Once you have the short circuit current and open circuit voltage for any network with dependent source or with independent source, we can find the RTH. What is the value of the RTH? Always remember this formula: open circuit voltage upon short circuit current. Open circuit voltage is nothing but VTH, short circuit current is nothing but Norton's current. So what is the value here? 2 volt divided by what is the value of this? 3 by 4, and this will become what? 8 by 3 ohm. 8 by, like this. So this is the formula. RTH is equal to VOC by SC. You can use this formula to find the value. Okay. ये एक मेथड है, तो ये भी this you can use this method for what dependent sources also. But sometimes in what exam hall, sometimes we are not getting how to solve that particular question. Simply find the VOC, then find the ISC, divide it, and you will find the RTH. Now, what is the answer for this question? How many students give the answer for dependent source? Now, this was with independent source. Very, very simple question. That is the answer for this question. That is what 2 volt, that is the 6 by 8 or 8 by 3 ohm is the resistor. Divide these two resistor and you will get the answer 8 by 3 ohm by this method. Or directly you can find the R equivalent. When there is no dependent sources, this method is very, very easy to find the RTH. Okay. All good. Now, if there is dependent source, if there is a dependent source, then how to solve this type of question? Simply solve this. Watch this one. First of all, what is the open circuit voltage means what is the VOC here? What is the VOC here? Now simply VOC means, let's try to understand. What is the current here? 1.5 Ix. It depends. This is a current controlled current source. Ix is going here. What is the current in this branch? 1.5 Ix minus Ix. So here it is a 0.5 Ix. 0.5 Ix is the current in this direction and Ix is the current in this direction. This Ix will flow through the 4 ohm resistor, then VOC will become 4 times of Ix. This is the equation number 1. VOC is nothing but VTH. Then how to find Ix? Always remember, we can't write the KVL through what voltage source. Then simply write down the KVL from this point to this point. When I am writing the KVL, remember this is the -6, I am going like this. This is the -6 volt. This is also minus, this is plus, this is minus. So minus 0.5 Ix into 5 plus 3 plus 4, 7 Ix is equal to 0. Now this will become minus 2.5 plus 7 is equal to 6. Now Ix, you can find the value of the Ix is equal to 6 divided by 4.5, right? Or you can say 12 divided by 9 multiplied by 2 and 2. This is the 12 by 9 ampere. Now what is the VOC multiplied with the 4? Then VOC is equal to VTH is equal to 4 into 12 divided by 9, and that is nothing but, right, this is a 3, 4, 4, 16 divided by 3 volt. How many students are getting the answer 16 divided by 3 volt? Yes, Chinmay, your answer ISC is correct. Yes, 5.33. Yes, Manohar Hussain, your answer is absolutely correct, 5.33. That is what 16 divided by 3. Easy. 16 divided by 3 volt. Now, once you have open circuit voltage and you want to find the complete Thevenin's equivalent, then you have to find the RTH. Then find simply ISC. You can also find the ISC, then that will become very easy for you. Then I will give the next method. Connect ISC here. When I am connecting this to making short circuit, this is the current ISC. What will be the current here? 0. Why 0? Because there is no drop. The drop across this is 0. This is the reference. And that's why this current Ix will pass through this. Then ISC will become Ix. Again same thing, this current is 0.5 Ix, current distribution rule. Now simply write down the KVL from this point to this point through a short circuit. It will become -6. Minus 5 into 2.5, this is the plus, this is the minus. 2.5 ix plus what, 3 ix, this time it is 0, written back to here, is equal to 0. This will become 3 minus 0.5 ix is equal to what, 6. So what is the ix? Nothing but ISC is equal to 12 ampere. Are you getting me? Are you getting me? This is simply we are finding the short circuit, because already we have the open circuit voltage. Then just make it short circuit. What will be the current? 0. Here the current is ix, here is the current is the 0.5 ix. Write down the KVL, minus 6 minus 2.5, 5 into 0.5 is 2.5 ix plus 3 ix, this is the 0, and then solve it. This is the 6, this is the 0.5, and you are getting the 12 ampere. This is nothing but Norton's current. Norton's current. Now, what is the RTH? RTH is nothing but VOC upon ISC. Tell me what is the answer? 16 by 3 divided by what? 12. So this will become 4, this is divided by 4, 4 upon 3 into 3, that is the 4 by 9. Are you getting this 4 by 9, right or wrong? Tell me, everyone. Manwar Hussain, you are getting the 4 by 9? So what is the unit? Please always give the unit also. 4 by 9 ohm. This is the 16 by 3 volt. That is one method. Why we are choosing this method? Because already we have find a VOC. Then simply we can find the ISC. VOC upon ISC. Yes, Ministry of Railway. Wow, Mansi Chauhan. Yes, 4 by 9.44 ohm. Now what is the second method? In same question, because we have answer, in second method you can use, normally we are choosing, suppose second method, simply if only question is given here, find RTH only, find RTH, then this method will become very lengthy. RTH means first of all find the VOC, then find the ISC, so this will become very lengthy, and that's why if directly RTH is asked, yes, Venu Kumar, VOC upon ISC is applicable for dependent sources, independent sources, right? Already I have solved one question on independent sources. That is the another question on what? Dependent sources. Yes, it is applicable, right? Okay. In this case, first of all, always remember, so what is the second method? Method 2. Method 2, make all independent active sources. Always remember this point. All independent active sources is equal to 0. Means if there is a voltage source, make it short circuit. If there is a current source, make it open circuit. Active, independent. Dependent sources is also active sources, but independent active sources. Independent active sources means this one. Make it 0. 6 volt will become 0. It will act as short circuit. Now apply 1 volt battery here, or 1 ampere current source. So one by one I will give the method. So you will get the, for one question we have the answer 0.44. That's why we can experiment. Now, first of all, make it 0. Make it 0. Short circuit. Independent active sources. Dependent will remain here. Connect a test battery, 1 volt battery. Let 1 volt battery. Let this is the current I because of this battery. Then RTH will become 1 by I. This is the RTH. Try to understand. This is the IX, this is the I. So what will be the current here? I plus IX. I plus IX. Now you have to find the 1 by I. What is the current here? Again 0.5 IX. 0.5 IX. This is the 1.5 IX. This is the 0.5 IX. This is the 1 volt. Now you can write a KVL here and you can write a KVL here. So what is this? 1 divided by 4, or you can write 1 is equal to 4 times of I plus Ix. We want 1 by I, that's why we have to replace Ix. This is the equation number 2. Now write down the KVL from this point to this point. You will write minus 1, this is the minus 3x, this is the plus, this is the minus 3x, 3ix plus 5 into 2.5, it will become 2.5 ix is equal to 0. Now give me the value of the ix. This is the 1 there, and this is what, minus 0.5 ix is equal to 1 here. What is the ix is equal to? Take my calculation, minus 2 ampere. Ix is equal to minus 2 ampere. Right, up to this point everything is fine. Okay, now put here minus 2, then it will become 1 by 4 is equal to I minus 2, and here this is the 2 plus 1 by 4 is equal to I. 9 by 4 is equal to I. So what is the 1 by I? 4 by 9 ohm. 4 by 9 ohm. Yes. So again we are getting the same answer. So if suppose you want to find only RTH, then this method is better. This method is better. Only RTH. But complete Thevenin's is required, then that method is better. Already we have the VOC, then simply find the ISC and get the ratio. We have the VOC, find the ISC and then get the ratio VOC upon ISC. I think this question is clear to you. Yes, everyone. In every case we are getting the same answer, 4 by 9, 4 by 9, 4 by 9. Now last method. Some students are interested with what? Sir, I want to connect a 1 ampere battery. Okay, no problem. You can connect a 1 ampere battery also. Let this is the 1 ampere battery. Okay, please everyone watch this. That is the method. 1 volt battery, then it will become 1 by I. So this is the answer. You have to find the 1 by I. Write down the KVL, arrange this and you will get the answer. 1 ampere battery, then what is the method? Let this voltage will become V. Voltage across the battery will become V, then RTH is given by V by 1, that is nothing but V. This is the another method, the third method. Now second thing, always remember, when we are connecting a test battery, always make the dependent sources is equal to 0. This will become 0. Right? Same distribution, the current is 0.5 Ix. Here it is the Ix. Now 1 ampere current is here, so you can write 1 plus Ix. 1 plus Ix. 1 here, Ix here. What is the current? 1 plus Ix. Directly you can write V is equal to 1 plus Ix into 4. We have to find the V. To find the Ix, write down the KVL. With current source we can't write the KVL. To write down the KVL from this point to this point, when I am writing the KVL, minus 3Ix plus 2.5 Ix, move like this, minus 4 times of 1 plus Ix. One plus 1 minute. Yes, 1 plus Ix is equal to 0. Then this will become minus 0.5 minus 4 minus 4Ix is equal to 0. This will become minus 4.5 Ix is equal to 4. What is the Ix is equal to? Minus 4 divided by 4.5. Very simple, right? So 1 volt battery or 1 ampere current source. This is a 1 ampere current source I am connecting. Now once you will get the Ix, this is the equation number 1. right? Put here in 1, you will get V is equal to 1 minus 4 upon 4.5 into 4. Tell me what is the answer here. V is equal to 4.5 minus 4 is what? 0.5 divided by what? 4.5 into 4. That will become 2 divided by 4.5, or we can simply say this is nothing, multiplied with 2 and 2, it will become 4 divided by what? 9 ohm. 4 divided by 9 ohm, or simply this is 0.5 is 1 by 2, 4 divided by 9. Directly you can write here. Is it clear? Acha, Ministry of Power, 1 ampere or 1 volt, how to know which is easy? Right, in some questions, for example, in this type of questions, both method will take same number of steps. Yes or no, Ministry? You know, in this we are using the 1 volt battery, same number of steps. Right? Or if we are taking the 1 ampere current source, same number of steps. Right? But if we are having the number of branches in parallel, then you can take 1 ampere current source. It will become very easy for you to distribute the current. If we are having the number of components in series, then you can choose what? That battery, 1 volt battery. But it is a question to question, it may vary, or it depends upon the person. Okay. Sometimes it will become very easy for you. Okay. So solve around 10 to 20 questions on that, and in exam hall you will get the idea for particular question which method is better. There is no universal answer for this. Okay. Now next question, my dear friends. ये तो हो गया, that is already we have solved with the 1 volt battery, already we have solved with the 1 ampere current source and VOC upon ISC. Now my dear friends, I want the answer for the next question. What is the answer for the next question? Find the Thevenin's equivalent of the circuit in the figure at terminal AB. I am choosing this question because this is one battery is connected here, 1 2 ohm resistor is connected here, 6 ohm is connected here, 2 ohm is connected here, Vx is connected here, 5 ampere is connected here. Which type of question? R in and out. Yes, in case of BJT, when we want to find the RTH, output resistance, then we are using the same method. But to find the R in, we are using what? V in upon what? I in. V in upon I in. Yes. Now, find the Thevenin's equivalent. Suppose we want to find the Thevenin's equivalent. One thing is important. We want VOC here. Right? We want VOC here. We want RTH here. Then, if we have a resistor parallel to a voltage source, whether it is a dependent or independent, this is R. It is a voltage source. It is not a current source, it is a voltage source, V. Then it is equivalent to what voltage source? V. If I am having a dependent source, again I am having one resistor here. Again you can remove this resistor and simply it is a simple dependent source because it is a voltage source. This is the 2Vx. It doesn't matter what is the value of R, the voltage between these two terminals will remain same. So you can remove this 2 ohm resistor from this point. Okay, that is the method of what? Super mesh analysis. Number of questions on super mesh analysis. New students, if you want to solve some important numericals on super mesh analysis, already I have given you the idea from in first class. Sardicu, Alexander and Sardicu, right? That is a textbook. Or again, if you want some basic question, already I have mentioned one book. So please watch my first session. How to get the command over circuit theory, complete strategy, each and everything about what network and what about the weightage and each and everything I have given. Okay, so already please subscribe the channel so that you will get the link. Join my Telegram channel, that is what Electronics by Sanjay Rathi. Electronics by Sanjay Rathi. Now I will share the link with you. Now remove this 2 ohm resistor, 2 ohm, 6 ohm. Give me the answer. Just I am sharing the link with you, everyone. What is the answer for this question? and then after that we will solve some two important questions. Tomorrow we have one practice session on this, complete practice session on dependent sources. Yes, everyone, give me the answer. Just I am sharing the link with you. Okay. So I will upload the PDF of this class on this Telegram channel, that is Electronics by Sanjay Rathi. Everyone please join that Telegram channel so that you will get the proper PDF, proper notes, okay, and some important concept about what network, important numericals, some practice question, okay. Now, so what will be the answer for this question? Simply, first of all, remove this 2 ohm resistor, right? If you want VOC, very simple. Remove this. Once you will remove this, let the voltage, open circuit means what is the current here? 0. At this point the voltage is VOC, right? And let this voltage, what is this voltage? Vx here. We have the two nodes with reference to ground. We have the voltage Vx here, we have the VOC. So first of all, we have to apply the super nodal analysis. So VOC minus Vx, VOC minus Vx, this is the VOC minus Vx is equal to 2Vx. Because it is plus, it is minus, we are writing VOC minus Vx is equal to 2Vx. So from this you will get the VOC is equal to what? 3Vx. And that is the equation number 1. Now write down the KCL at this point. When I am writing the nodal equation, so what is the incoming current? Super nodal equation, super node. What is this method? Consider this node. So what is the incoming current? 5 ampere is equal to, what is the outgoing current? Vx by 4. Now jump here, VOC by 6. And what is the current in this branch? 0. This is called super nodal analysis. Now you can take 12 as the LCM. This will become 3Vx plus what? 2VOC. And this is the 5, equation number 2. Always remember, be careful. What is the 3Vx is equal to VOC from equation number 1? 3Vx is equal to VOC. And we want to find the VOC. So please put here VOC, and this is the 12. This will become 60. VOC plus 2 VOC, and VOC will become 60 by 3. That is what? 20 volt. Very easy. Always remember this method. So I think this question is very easy for you. Give me the comments. Yes, are you getting 20 volt? So first of all, remove this VOC. Always remember, this is an open circuit. That's why there is no current through the 2 ohm resistor, because there is a one voltage source in between these two nodes, and that's why we have to apply the super node. VOC minus Vx is equal to 2Vx, and that is the equation, and then super nodal equation, and you will get the answer 20 volt. Okay. Now again, if you have the value, then second method, then simply in this question remove the 2 ohm, and you can use the method here. Remove this 2 ohm resistor. Remove this current source. Always, if this is a current source, make it open circuit. Make it open circuit. Because we have one dependent source, then you have to apply 1 volt battery here, and let this is the I. Let this is the I. Then RTH will become 1 by I. Okay, RTH will become 1 by I. Now what is the voltage here? 2Vx. So what is the voltage here? Vx, right? So what is the voltage here? 3Vx. 2Vx plus Vx is equal to what? 3Vx. what is the current here? 3Vx by 6. This will become Vx by 2. Now this is the incoming current I. Here is the current is Vx by 2. So what will be the current here? I minus Vx by 2. I minus Vx by 2. That is the current here. I minus Vx by 2. This current will pass through this. I minus Vx by 2. Now you can write one equation. Vx is equal to 4 into I minus Vx by 2. Then Vx is equal to Vx is equal to 4I minus 2Vx. Please check my calculation, and this will become 3Vx is equal to 4I. What is the Vx is equal to 4 by 3I. This is one method, just one method. Tamil, yes, बोलिए. आपको आ गया समझ में? This is one method. Once you will get the Vx, right? Now write one equation here. Write one equation here. It will become 1 is equal to 2I plus 6 into Vx by 2. 1 is equal to 2I plus 3Vx. My dear friend, what is the 3Vx? We will directly use 4I. 1 is equal to 2I plus 4I, that is equal to 6I. So what is the 1 by I is equal to 6 ohm. 6 ohm. So that is the answer, 6 ohm. Right. Now, if suppose we are having the VOC, then 6 ohm is the answer. Now you can try the same question with different methods. Normally students are solving what different questions by different methods. But my approach is simply, if I am having one question, let it is the answer. For simple comparison, try to solve that particular question by different method, just for your practice. Because in exam hall we have to use simple one method, right? So we have to choose what? Efficient method, right? Less time consuming method. And that's why simply try to solve each and every question once or two or three times. For example, if we have the VOC, then simply make it what? That is a question. 1 minute, give me 1 minute. Already we have the VOC. Already we have VOC. What is the second method? Simply find the ISC. Find the ISC. And answer is what? 6. Okay, no problem. This is the VOC. Make it now short circuit. This is the ISC. Again remove this. Remove this 2 ohm resistor. Already we have solved. That's why number of steps, repeated steps. This is the 2Vx, this is the Vx, and that's why at this point it will become 3Vx. And what is the ISC is equal to 3Vx by 2. This is the 3Vx, this is the reference, 3Vx by 2. We have to find the 3Vx by 2. Now the super nodal analysis, at this point we have to apply the super nodal. This is the directly we can say 2Vx plus Vx is equal to 3Vx. What is the 5 is equal to Vx by 4 plus 3Vx by 6. This is the 3Vx by 6 plus 3Vx by 2. 3Vx minus 0 by 2. You can take 12 as the LCM. This is the 12. This will become 3Vx. This will become 6Vx. This will become 6 into 3, 18Vx. Now, is equal to 5. This is equal to 5. So, 12 into 5, 60 is equal to 3 plus 9 plus 18, 27Vx. What is the Vx is equal to? 60 by 27. That is nothing but you can divide it by what? 3. That has become 20 divided by 9. volt. 20 divided by 9 volt. Now what is the ISC? 3 Vx by 2. 3 Vx by 2. That's why ISC will become 20 into 3 divided by 9 into 2. So this has become 3, 10 by 3. 10 by 3 ampere. This is the ISC. ISC, yes. So this is the ISC. Then what is the answer? What is the RTH, my dear friends? VOC upon ISC. What is the VOC? Already VOC we have the 20 volt divided by 10 by 3. What is the answer? 6 ohm. So RTH again we are getting the 6 ohm. So because already we have VOC, then it will become very easy for you to calculate what ISC. Once you will get the ISC, VOC upon ISC, and we have the VOC directly ISC, and I get the answer. Then no need to apply this. If only RTH is required, then okay, no problem. For example, in maximum power transfer theorem, we have to calculate what? VTH as well as RTH, right? And what should be the value of RL? RL should be equal to RTH. Then already we have to find the VOC. Then we can find the RTH by using the VOC upon ISC. Then we can find the maximum power. That is the method. I think up to this point everything is clear. Now, my dear friends, tomorrow we will solve this question. That is the assignment for you. Assignment number 1. How many students are interested? How many students are interested to solve some questions, some important questions? Because you will get sufficient time, right? And tomorrow at same time 10:30 p.m. with these numericals and some important numericals from what previous year GATE paper from 3 branch: electronics, electrical, and what instrumentation branch, right? And some questions from standard textbook. Some questions from standard textbook like what Sadiku, like Van Valkenburg. Okay, selected numericals so that you will get the command over this. Sir, tomorrow please explain RTH in definitely Venu Kumar. One question on what? Negative RTH. If suppose I am getting the negative RTH, then what is the case? Why we are getting the negative RTH? Okay, definitely. Okay, so tomorrow this is the assignment. For the circuit shown in the figure, the Thevenin's voltage and resistance looking into the XY. That is the first question. This is the 2I, my dear friends. This is the 2I. This is the 1 ohm resistor. This is the 1 ohm resistor. This is the I. Because it is depends on this 2I. 2 ampere current source. 2 ohm. You have to find the voltage, Thevenin's voltage and resistance across X and Y. This is the 2 ohm. You can take a screenshot of this. Okay. Second one. This is the first numerical. And this is the second one. For the circuit shown in the figure, the Thevenin's voltage and resistance. Again on dependent source. Like this is the Vx or VR we can say. And this is the VR. VR divided by 500. This is the 250 ohm, 250 ohm. This is the VR. This is the VR divided by 500. Voltage controlled current source. 5 volt battery. And find the Thevenin's and voltage resistance. Right? Take care of what? Time management. Within time, you can't take what 20 minutes or 30 minutes. Simply try to solve within 2 to 3 minutes. Maximum 2 to 3 minutes. Maximum. Right. Again. Now this is the last question, assignment number 3. This is the 5I1. 5I1. This is the I1. This is the, again, watch this. This is the I1. This is the I2. This is I2. 2I2, I2, 5I1, I1. Right? And try to solve this question. This is the 5I1. This is the I1. This is the I2. That is the 2I2. And you have to find the RTH at this point. RTH at this point. Okay. We have the 2 dependent sources in this diagram. 5I1, I2, then 2I2, this is the I1, okay. So, yes, try to solve this question. This is all about what? Thevenin's theorem with what dependent sources. So don't worry about the dependent sources. Try to solve around 10 to 20 questions on this. 10 to 20, if you are able to solve around 10 to 20 questions, then you will get the command over this topic. A very simple strategy, but variety of questions. And try to solve one questions by different methods. One question by different method means what? VOC upon ISC, first method. Second method, 1 volt battery and current I. And third method is what? 1 ampere current and voltage. Okay, RTH is equal to V, RTH is equal to 1 by I, or RTH is equal to VOC upon ISC. Okay then, thank you for attending the session. Share the link of this session, subscribe our channel and simply like the session. Okay then, thank you and good night. Thank you.